Have you ever gazed up at the night sky and wondered why Saturn, among all the planets, is adorned with such magnificent rings? Saturn, the sixth planet from the Sun, is a gas giant that stands out in our solar system, not just for its size, but for its ring system. This majestic planet is not the only one to sport rings. Jupiter, Uranus, and Neptune all have ring systems of their own. However, none of them can match the grandeur and complexity of Saturn's rings. These rings, composed of countless particles, stretch out more than 200,000 miles from the planet, yet are incredibly thin, often just about 30 feet in depth. They are primarily made up of ice particles with a smattering of rocky debris and dust. This icy composition is why the rings shine so brightly when viewed from Earth. They are reflecting sunlight. The rings themselves are divided into 7 major divisions, labeled alphabetically from A to G, in the order they were discovered. Each ring is unique, varying in width, opacity, and composition. The most prominent of these, the A, B, and C rings, can easily be seen through a small telescope. Saturn's ring system is a dynamic and ever-changing wonder. The particles within the rings range in size from tiny, dust-sized icy grains to larger chunks as big as mountains. These particles constantly collide, causing them to break apart and reform. What's fascinating is that despite their chaotic and violent nature, these collisions result in a beautifully structured ring system. The ring's intricate patterns and structures are a result of gravitational interactions between the particles in the rings and Saturn's many moons. So Saturn's rings, as mesmerizing as they are composed mainly of ice particles. But how did they form in the first place? The origin of Saturn's rings has been a subject of much debate among scientists. Their beauty and complexity have sparked numerous theories about how they came to be, with 2 main hypotheses gaining prominence over the years. The first theory proposes a catastrophic scenario. It suggests that the rings formed from celestial objects, comets, asteroids, or even moons, that ventured too close to Saturn. The mighty gravitational pull of the planet tore these bodies apart, leaving a trail of icy debris that eventually formed the iconic rings we see today. Imagine the sheer force of Saturn's gravity, powerful enough to rip apart a moon and gentle enough to sculpt a masterpiece in the sky. The second theory takes us back in time, to the very formation of Saturn itself. According to this hypothesis, the rings are remnants of the protoplanetary disk, the cloud of gas and dust from which Saturn was born. Over billions of years, this leftover material resisted being drawn into the planet, instead coalescing into the stunning array of rings. They are, in essence, a glimpse into Saturn's past, a cosmic time capsule holding secrets of the planet's birth. These theories, while compelling, face their own set of challenges. The catastrophic theory struggles to explain the purity of the rings, which are composed almost entirely of water ice. If the rings were the remnants of a destroyed celestial body, we'd expect a more diverse composition. The theory of rings as leftovers from Saturn's formation, on the other hand, grapples with age estimates. Observations suggest that the rings may be much younger than the planet itself, introducing a paradox. Despite the theories, the exact origin of Saturn's rings remains a mystery. But what we do know is how these rings behave and evolve. And isn't that the beauty of space exploration? The more answers we find, the more questions arise, keeping our curiosity forever piqued and our sense of wonder alive. Saturn's rings are not static, they are dynamic and ever-changing. Now that's something to wrap your head around, isn't it? Let's delve deeper into the dynamics of these celestial splendors. To start with, Saturn's rings aren't one big, solid disk as they might appear from afar. Instead, they are composed of countless small particles, each orbiting Saturn on its own path. These particles group together to form what we call ringlets, and the spaces between are known as gaps. So, you see, what looks like a solid ring from a distance is actually a bustling highway of cosmic debris. But what causes these ringlets and gaps? Well, it's all down to gravity. Saturn's moons, with their substantial gravitational pulls, play a significant role in shaping the structure of the rings. Some of these moons, known as shepherd moons, orbit within the rings themselves, their gravity carving out gaps and corralling particles into ringlets. It's a bit like a celestial shepherd herding its flock. Now let's talk about another intriguing phenomenon: spokes. These are temporary dark spots that appear in the rings, and they've had scientists scratching their heads for a while. It turns out, these spokes are associated with electrostatic charges. When small dust-sized particles in the rings get an electric charge, they can levitate above the ring plane and spread out, creating these dark spokes. It's a bit like watching a magic trick, only it's happening millions of miles away in space. So from ringlets and gaps shaped by the tug of gravity to spokes created by electrostatic charges, Saturn's rings are far from static. They're a cosmic dance of particles and forces, always moving, always changing. These dynamic forces keep Saturn's rings in a constant state of flux. But how can we study these distant rings? To uncover the secrets of Saturn's rings, scientists have relied on spacecraft and ground-based observations. Guided by curiosity and armed with cutting-edge technology, we've launched several missions to study Saturn's rings, each one revealing something new and exciting. The Voyager missions in the late 20th century were some of the earliest endeavors. Voyager 1 and 2, as they're called, gave us our first detailed look at Saturn's rings. Their images and data showed us that the rings were not solid, but composed of countless small particles, each orbiting Saturn on their own path. But the Voyager missions were just the beginning. The Cassini-Huygens mission, launched in the late 90s, took our understanding to a whole new level. The spacecraft spent over a decade orbiting Saturn, studying its rings in detail. Cassini-Huygens not only sent back the most detailed images of the rings we've ever seen, but it also discovered new rings that we had not known about before. One of the most surprising discoveries of the Cassini-Huygens mission were the propeller-like structures in the rings. These structures, which can be as wide as 50 kilometers, are caused by small moonlets embedded in the rings. As these moonlets move through the rings, they create disturbances that look like the wake of a boat on water or the propellers of a plane in the air. The images sent back by Cassini-Huygens showed us that Saturn's rings are far more complex and dynamic than we had ever imagined. They're composed of countless particles, ranging from tiny dust-sized particles to large chunks of ice, all orbiting Saturn in a delicate dance. The rings also contain features like spokes, waves, and braids, created by the gravitational interactions between the particles in the rings and Saturn's many moons. These missions have revolutionized our understanding of Saturn's rings, revealing a world of intricate beauty and celestial ballet. They've shown us that Saturn's rings are not a static feature, but a constantly changing system, shaped by the intricate interplay of gravity and motion. Saturn's rings are more than just a beautiful sight in the night sky. They're a complex system that continues to captivate scientists and space enthusiasts alike. As we delve into the intricate details of these celestial bodies, it's important to remember that Saturn's rings are composed primarily of ice particles with a smattering of rock debris and dust. These aren't just any ice particles, but ones that have been around for millions of years, possibly even billions. They're a glimpse into the past, a frozen testament to the history of our solar system. The origin of Saturn's rings, however, is still shrouded in mystery. There are theories, of course. Some suggest that the rings are remnants of a shattered moon or other celestial body that got too close to Saturn and was torn apart by its gravity. Others propose that the rings formed alongside Saturn itself, coalescing from the same cloud of gas and dust that birthed the planet. But the truth is, we don't know for sure, and that's part of the allure. Then, let's not forget about the dynamic nature of these rings. They're not static, but constantly in motion, shifting and changing under the influence of Saturn's gravity. The rings are a complex dance of particles, a ballet on a cosmic scale that we're only just beginning to understand. But how do we study these far-off rings? With technology, of course. Observatories and space probes like the venerable Voyager and Cassini missions have given us unprecedented views of Saturn's rings. These missions have allowed us to study the rings in detail, revealing their composition, structure, and the intricate interactions between the particles. As we continue to explore the cosmos, Saturn's rings remind us of the beauty, complexity, and mystery that await us in the depths of space. So, as we ring in this new year, let's celebrate the wonders of Saturn's rings, the mysteries they hold, and the questions they inspire. Because who knows what discoveries the future might bring.